Okay, in this lesson we're going to continue to look at linear inequalities, and the last critical lesson what I looked at is explaining what linear inequalities are, and what we noticed, or just to define it, is that it's a relationship between two expressions where one is less than, greater than, less than or equal to, or greater than or equal to the other expression. The solution set is the set of all possible solutions, and it can be represented on a graph. So what we noticed in the previous lesson is generally inequalities will have some sort of boundary line between all the solutions and the non-solution. So there's going to be some sort of line here where half is a solution and the other half is not. Or here's an example here. This is where y is less than negative 2x plus 4. We've got a boundary line, and these are solutions and these are not solutions. We're going to look at now how do we actually graph these. So in the last lesson it was a description of what are linear inequalities, and this it is how do we actually describe them. One thing that we noted last time, and you might want to look at that video, is that this boundary line is important because this boundary line tells us where the solutions and the non-solutions differ. So the observation that I made in that lesson is that the boundary line, when we're looking at an inequality, is where the two expressions are equal to each other. So instead of using the inequality sign, we look at where these are equal instead of less than or equal to. So that's where my boundary is going to lie. And now we're just actually graphing a line because it's a boundary line. Where does y equal negative 2x plus 4? And the easiest way to do this is to find two intercepts, or generally try to just substitute x equals 0 into the function. So we'll have y is equal to negative 2 times 0 plus 4, or in other words, y is equal to 4. So that represents when x is equal to 0, y is equal to 4. That's this point right here. And the next part would be if I substitute y equals 0, because in order to graph a line I need 2 points. This would be 0 is equal to negative 2x plus 4. So I could solve algebraically. I'd have negative 4 is equal to negative 2x and divide by negative 2, and I'd have x is equal to 2. Or in other words, x is equal to 2 when y is equal to 0. So it would be this point here. So our boundary line, as you can see, would look something like this. Okay, and as you can see in the solution, this is the exact same example. We've got a boundary line now. Now we need to find out which side represents solutions and which side doesn't. And what we do there is we choose any test point. I tend to choose the point 0, 0. So for example, if the point 0, 0 is a solution, then all of the points on that side of the boundary will be solutions. So that's called a test point. Generally use 0, 0. So if I test 0, 0 in the original inequality, so I'm going to test 0, 0. So substitute 0 in for y and x. Is 0 less than or equal to negative 2 times 0, which is 2 times x plus 4? So 0 less than or equal to 0 plus 4. Is 0 less than or equal to 4? And the answer there is yes, 0 is less than 4. So since that's a solution, everything on that half of the boundary line will also be a solution. So all of these points represent solutions to this inequality. Y is less than or equal to negative 2x plus 4. In our next one, I'm just going to do all the left-handed ones. You'll see why in the next lesson. In the next one, you'll notice a similar pattern. So I have the answer right here. So here's what the solution is going to look like, but let's look at how we do it. Now we've discovered that the boundary line is going to be where negative 2x plus 5y is equal to 10. So if I substitute x is equal to 0 into the function, I'll have negative 2 times 0 plus 5y is equal to 10. And that's going to be 5y is equal to 10, because anything times 0 is 0. And divide by 5, I'll have y is equal to 2. So in other words, when x is 0, y is equal to 2. And that's this point right here. And if I substitute y equals 0, I would get negative 2x plus 5 times 0 equals 10, which would get me negative 2x equals 10, divide by negative 2, and I have x is equal to negative 5. So in other words, x is equal to negative 5 when y is equal to 0. So that's another boundary point on this, or a point on the boundary line. Now the other thing to investigate or to be aware of that I haven't mentioned yet is because it doesn't say or equal to, the boundary is going to be dotted because the boundary is not included. This does not describe points where the two sides are equal. So since it's not or equal to, the boundary line is going to be dotted. But a very similar concept. So if it says or equal to, it's going to be a solid line because it's included. If it doesn't say or equal to, then it's going to be a dotted line. So here's our boundary line. That'll be mentioned again in future lessons. Now we want to find out which half of that boundary, you can see it's going to be this top half, is shaded. But let's just test 0, 0. Let's see if 0, 0 is a solution. So I'm going to test 0, 0 in here. So when negative 2 times x, which is negative 2 times 0, so is negative 2 times 0 plus 5 times 0 greater than 10? Well, that's going to be 0 plus 0 greater than 10. Is 0 greater than 10? That's a big fat no. So that means that the opposite half of the boundary line from 0, 0, all of this side will not be solutions, so this opposite side will be solutions. And as you can see, that's our solution. We'll just look at two more that are slightly different, but very similar. So if you flip the page, you'll see these two. You might want to pause these at any point in time. But exactly the same. The boundary line is where negative 3y plus 6 is equal to negative 6 plus y. What you'll notice here is that there is no x coordinate. So we looked at this in a lesson where there's only one coordinate. The boundary line is either going to be vertical or horizontal. If it's a y coordinate, it's going to be horizontal. So let's just isolate y algebraically. So if I maybe subtract y and subtract 6, it's going to cancel these out and cancel these out. I have negative 4y is equal to negative 12. Or in other words, your boundary line is where y is equal to 3. So that's your boundary line. There's no x coordinate. So y is equal to 3 right here. And it's going to be a solid boundary line because it does have the or equal to. So that means it's going to be solid. Now pretty straightforward again. What I'm going to do is investigate to see if 0, 0, one half of this boundary line is going to be shaded because it'll represent all the solutions. I'm going to test 0, 0. And since there's only a y coordinate we need to test in the original, I'll just substitute the y coordinate into here. So as far as our test point goes, is negative 3 times y, which is 0, plus 6, greater than or equal to negative 6, plus y, which is 0. So that would be, is 6 greater than or equal to negative 6? And that would be yes, it is greater than. So that means that all the solutions would be on this side where 0, 0 was a solution. And the last example that we'll do is this one here. And the focus is right here. You don't have to worry about any of that other stuff. That'll be a focus of the next lesson. So just 2y plus x greater than 0. So the boundary is where 2y plus x is equal to 0. So if we substitute x equals 0 in, we have 2y is equal to 0, divide by 2, and you get y is equal to 0. So when x is equal to 0, y is equal to 0. So that's a point on my boundary line. The tricky thing here is if I substitute y is equal to 0 into the function to get my other point on the boundary line, I'm going to get the same point. So that's going to be x is equal to 0. So when x is equal to 0, when y is equal to 0, x is equal to 0, the same point. And we need 2 points to define a boundary. So choose any other x coordinate and just substitute it in. So I'm just going to maybe substitute x equals 2 into the function. So 2y plus 2 is equal to 0. So if I subtract 2, I will get 2y is equal to negative 2. Divide by 2, and I have y is equal to negative 1. So this is a special case. When your coordinate is the origin, or when your intercepts are the origin, you just choose any other point. And what we noticed here is when x is 2, y is negative 1. So when x is 2, y is negative 1. So this is our boundary line, and it's going to be dotted because it's not equal to the boundary line. You see the inequality sign. A little bit of a tricky concept. You might want to rewatch this video. It's not or equal to, so it's going to be dotted. So let's just figure out which side of this boundary line is going to be shaded. We can't test 0, 0 because it's on the boundary line. We need to choose some point that's not on the boundary line. So I'm going to test the point 1, 1. So if I substitute x is 1 and y is 1 into here, is it true? So is 2 times 1 plus 1 greater than 0? Or is 2 plus 1 greater than 0? And yes, absolutely, it is. So that half of the boundary line is going to represent all the solutions to this inequality. And there's an introduction, a very hard one, but nonetheless, I think you'll get it.